Good morning, everyone. Thanks, John and RCA, for having me. Okay. Oops. Thank you. So I'm going to talk about how we can bring the LTE to our rural communities, and the gentleman before me touched upon a lot of these technologies which we use in our military and academia before, and you'll see actually some of those technologies, how in a commercial world you take advantage of those technologies to bring them closer and closer to the end users where it's difficult. So and we'll briefly touch upon where are the costs. A lot of times we all get excited about, and Charlie was talking about my language. I speak all these languages, the PHY, the Mac, and security. But when you step back and say what's taking so long, why it's still not everywhere, and that's really where you start to look a little different beyond the, let's call it, geeky nature of the technology into how do I do it most cost effective way. So we all have heard about that digital divide, and these are numbers. You can call it 2 billion, you can call it 3.7 billion. If you Google, you'll find about 60% of the world population, they're unconnected, they don't have broadband. And I was at a Facebook summit as well. Facebook is trying to do a great thing and trying to bring that number lower and lower. So I just wanted to ask, I was in upstate New York about 2 years ago, and we went to a place where half an hour before that, there was no coverage whatsoever. And me being an international traveler, I carry a bunch of SIMs, no operator whatsoever for 30 minutes to a place. And I was in a coffee shop and I asked the lady, so what do you do with this? You don't have a coverage. We got the landline phone, and she was happy, So I wanted to ask actually, how many of you know a place in US where there is absolutely no coverage? Plenty of hands. And so a lot of times we talk about the digital divide really for the poor countries, but actually in US, in UK, where we have a lot of these deployments, a lot of places we have the same challenge. It's exact same challenge. And the sad part is, it's one of those things, if you bring the coverage to the people, great things happen. And as we were deploying these networks in rural UK, as a founder, I wanted to go and ask the question, just like the gentleman wanted to understand from the soldier why he loved the radio. I wanted to know what they were really looking for. So as a deployment, the first thing we wanted to do was 3G, then 4G. And to my biggest surprise, the farmer asked me, when are we getting 4G? So I didn't expect the word 4G from him. I said, why? Why do you need 4G? He said, my daughter lives far away. I could do FaceTime with her. Just think about it that way, right? So people know that these things exist. They're just dying to get this technology in their hand, and they sort of feel bad that they are being left behind. So again, these are a bunch of numbers really you look at, but the question is, how do we solve it, right? So when you ask operators, why do, if you go to Verizon or AT&T, you say, why are you not deploying these? And, you'll get a bunch of these numbers. I actually look at it very differently. And, if you go to a public company like Ericsson, and Huawei is not so public, but, you look at their financial, like Ericsson announced their financial results a few weeks ago, and go look at how their revenues are broken up. Where is in the equipment, where are the other ones? So I'll ask a question. Do you know which percentage of the revenue for, let's say, Ericsson comes from selling the equipment? Is it less than 50%? Less than 20%? More than 50% of their revenue comes from services. And Huawei, we all think, is the cheap manufacturer of equipment. More than 50% of their revenue comes from services, not from selling equipment. So the myth that we make the hardware cheaper and cheaper will bring down the coverage, that's not going to happen. And if you look at it, the costs in the network are everywhere. And unless you really step back and say, can I solve it in totality versus just make a cheaper and cheaper equipment, you're not going to, even if the radio was $0, what you can look at is it's just covering the 6% of the cost here. you still have a huge mountain to climb to bring the coverage to people, right? So this is where you have to step back and say, how do I take advantage of the technologies that are already here today and turn that into something that users can deploy without really worrying about the ARPU? Because what happens is, as you're obviously in rural communities, there are not many people, and the cost all of a sudden becomes exponentially more hurtful than if you were in the middle of, let's say, New York City, for example. You can afford, because eventually you'll recover your cost. In rural, it'll take you 5 years to recover. So all of a sudden, all these numbers become really big mountains to climb. Let's briefly touch about 5G as well. So a lot of times people say, hey, just like the farmer was asking, why not start with 4G? And as you roll out, you try one and then you try the other one. And we did turn on the 4G, probably a month later. People can ask, why not we just start with 5G? The challenge with the 5G is a more densification technology, really. So if you're looking at the towers, you need 10, 20 times more towers to do 5G because of the high waveform or the high spectrum which is being proposed today. So all of a sudden, all the challenges you're talking today for doing a 2G, 3G, 4G, multiply by 10 or 20, and that's the challenge if you want to bring the 5G to a rural community. So again, how do you solve these things? This is very recent data from, and some of these numbers, again, trying to emphasize, the rural communities are just the vast nature of having no coverage whatsoever. No 2G, no 3G, no 4G. And a lot of these actually have implication, not only a little inconvenience that you can't make a phone call, but God forbid some accidents happen. People are out there, businesses cannot be there. And one of the example, again, I'll use a rural community example. One of the businessmen, he had little cottages. He wants to rent them out. He needed a real-time update when those are available, when they're not available. And he wanted to provide a Wi-Fi access to their guests. That's our biggest selling point. We all need Wi-Fi in our hotel rooms. So these little things actually matter a lot than we realize. So these are not just inconveniences that, hey, for next 10 minutes I can't make a phone call. Actually, it's a lot more than that. So what are the solutions available today, right? So now I'm going to go, actually, to be honest, I didn't expect this to be that tech savvy. I was thinking a high level, but now I hear the Mac and IPsec and everything. I'll go deep dive in, and I'll even touch upon the ad hoc networks as well a little bit, and you'll see it here as well. So, and please feel free to ask any question, any depth you would like to understand. So what happens today when you deploy these networks? We all know a big ugly tower, right? And nobody wants in our backyard, right? I guess who would want in their backyard this tower on the left? Oh, wow. How about your neighbors? So that's the challenge, right? So what happens is operators, let's be honest, we all been there, right? These are cellular towers, not the public safety where you're on a different sort of scenarios. So what happens is, because these towers are very expensive, if you're doing a rural, you want to find the tallest tower so that you have a biggest line of sight and biggest coverage. That's what you're trying to do. Net result, more expensive. So a lot of these costs are actually sort of, if from the audio amplifier terminology, like negative feedback, that's what happens. Now you want the biggest tower. Now you want to do a perfect RF engineering so that the coverage, you try to cover every square inch, adds more cost into this. Now you want to provide the biggest backhaul, adds more cost into it, right? And nobody wants in their backyard, or a lot of people don't want in their backyard, with few exceptions. But your neighbors definitely don't want in your yard. So another challenge with this is rural communities. One of the things why they are rural communities, they are like clusters of homes, then big empty space with farm or wilderness or mountains, right? Those are the typical patterns of the rural communities. So when you build one of these big towers, what happens is, while they cover, let's say 30% of useful area, the 70% of the area they cover are not as useful, but you're still paying the cost of the infrastructure, the tower, and everything else. So that becomes challenging, and all of a sudden you can't really justify these costs. So what we try to do in parallel wireless, we, and my background has been some of this military communication ad hoc network, and as you say in French, manet background. So we try to bring in, hey, we have solved this problem for our soldiers. I know it's a little different context and different thing. Why not bring that into the mobile technology, right? One big site, you do four little ones, and they daisy chain with each other, and that now these four cells are closer to where the clusters of the homes are versus one big one. So that's the approach we take. So these are some simple requirements. So before I go into a little bit more detail about technology, let's just reflect, right? Needs to be cost effective, and we said cost comes from many different areas, right? The equipment cost is one, the backhaul cost is another one, and the one is the human cost, which is the services, as I said. That's actually the majority of the cost in the network. So how do you take that out? And you take that out with automation. If you can install it easily, and you don't have to send the RF engineers out there to do the drive test and optimize the coverage and minimize the interference, that's a huge saving. The second one is really plug and play. If you're not sending engineers out there, just like the soldiers, they show up on the site and they expect the radios to work. This is the same thing. If you're not sending RF engineers out there to install these LTE base stations, it needs to be really plug and play and needs to auto configure. Very similar to what you expect for Wi-Fi, right? In Wi-Fi, you just turn on your little Linksys router and it just works for you for most of the time, unless you live in apartments and you have too many neighbors using the same as Wi-Fi channels, right? So that's sort of the expectation. Other one is actually planning light. We use this terminology. Again, if you have a big ugly base stations, you'll run into so much neighborhood protests and deal with the community and getting the planning and permissions. So what if you take that, or I would say simplify that one, so that the neighbors are not as upset because they don't even know that there's a big tower in the backyard. And the backhaul is another interesting one, right? We cannot bring high-speed backhaul everywhere. I hope it'll come soon. There are many companies working on it, including Facebook, and many satellite-based solutions are coming up. But until then, what I like to call it, we should have a Swiss Army knife of backhaul approaches. Take advantage of whatever is available. We got 10 DSLs together. It's actually 100 Mbps, assuming it's a 10 MB down and 1 MB up. Now it makes sense, right? It's some number you could live with, and you can throw in a satellite. You can throw in some other like mesh backhaul. All of a sudden, together they are more powerful than individual ones. So can you take advantage of those? And last but not least, it needs to be future proof. If you start with 3G, you should be able to upgrade to 4G and potentially 5G. For example, let's say it's not voice or LTE today. You want it to be voice or LTE capable. So it's all about software defined radio aspect of it. And this is in the commercial world, you have to do that. Otherwise, operators don't deploy the solutions, and end users don't want it. You don't want your phone to just do 2G. You want it to do 4G and potentially 5G in future. So what you're looking at is, this is the world's smallest radio capable of running 3G and 4G at the same time. And there's a lot went into this to, the biggest thing what went into this is what we call is Moore's law, really. With the Moore's law, lot of equipment and the power consumption and power delivery of these components really became good enough to put everything into one box, versus trying to separate the baseband from the power amplifiers and filters. When you actually bring a lot of these technologies together, you remove a lot of middle layers from the network. And you needed to do that, like the baseband pooling, for those who you're familiar with. So what you would do is you will take bunch of FPGAs or DSPs, pool them in a chassis, because economies of scales weren't there, so you want to pool. And then you would take a fiber or some other, think as a bus, to bring them to power amplifiers and filters. So that's the technology used to be. When the baseband is really powerful, where it can deal with a full sector's worth of capacity, you don't need 10 FPGAs together to do that, or 10 DSPs. You just put one right in there and get rid of all the complexities of joining two different chassis together, get rid of the fiber, FPGA in and out to deal with the CPRI. That's one of the protocol you use when you have the radios decoupled from the baseband. And there's a huge saving actually when you step back and do that integration versus keep going the old model of chassis or pooling architecture, which made sense in the old days when things were expensive. Not anymore. It's just like we all have laptops. We don't have those little VT100 terminals like we used to, because what used to be the power of those mainframe, probably you have more power in your laptops most likely. So that's the same analogy. You don't need the you don't need the VT100 here and the mainframe down somewhere in the cabinet. You can afford a laptop, and this consumes less power than the MacBook 13 I have, really. So that's the efficiencies you're able to get. There are many techniques. I can go on, the digital pre-distortion to crest factor reduction. All these techniques you do, because unlike other waveforms, the LT waveform is, the peak to average ratio is about 8 dB, and if you just call it 9 dB, every 3 dB means you double. So if you were to do 10 watt, you're looking 20, 40, 80 watt of peak coming out of this, these antenna ports. So that's what you have to deal with. So there are a lot of techniques you use. These are all software techniques to somehow, if you can absorb few peaks at the expense of a little more error on your waveform or on your link, you can run it more efficiently. If you not do the MIMO, for example, you can run half the power of the power amplifier. So there are a lot of those techniques you can do. Why? Because if you're deploying them in the middle of nowhere, you probably could deploy them with the solar, and some of ours are, where these are not on a grid. You just put a solar array and a battery, and these will work very well there as well. So some of those things you're able to do when the power consumptions are low. So sometimes it makes sense, sometimes it doesn't make sense. It actually depends on where you are. So the power a lot of times plays a lot of role into how you deploy these networks. So what you're looking at here is, so another thing I say is, those of who you're following the 5G or the 3GPP sort of buzzwords, I call it. The mobile edge compute is another thing that's called 5G architecture. What it's about is bringing compute more closer to the radios. Think of it as, you want to do content caching, right? How you do content caching, if the contents were very close to the radio, you don't have to go to the backhaul, and you can do that, right? And similarly, software-defined network and virtualization, these are other hot topics in wireless industry for 4G and 5G. What I call it, actually, the rural communities will be the most beneficial out of these technologies. It's sort of counterintuitive. You think that, hey, rural, they can live with 2G, right? They don't need the network, software-defined networking. They don't need the mobile edge compute, right? Actually, it's the other way around. If you do mobile edge compute, let's say content caching, remember, they are backhaul challenged. They are the ones who will take advantage of it. If you are doing a downtown New York, they are not backhaul challenged. While you may save a few megabits or gigabits here and there for some backhaul, they can afford it, and they have much bigger pipe. So if you just look at the content caching, what you're doing for the middle of the city, you're saving maybe few milliseconds, 2 milliseconds of latency. That's really the net result. For the community, rural community who are backhaul challenged, what you're doing is actually you're providing them high definition Netflix video. That's day and night difference than what these technologies bring. Similarly, software-defined networking, right? Yeah, you can buy an open switch and save costs. what software-defined networking does here is, in a rural community, take advantage of these different backhauls available. What if these 4 radios had 4 DSLs, as I gave the example, 10 Mbps downlink and 1 Mbps uplink? Now you're looking at 40 Mbps. What if one had 10 Mbps DSL, one had a satellite, and one did a in-band backhaul? You can take advantage of all these different pipes coming in, so they not only add into the resiliency in case one of the link goes down. Now you look them in aggregate. For example, if you're doing a low latency communications, let's say voice over LTE, you can send it via DSL. That's still the lowest latency you got. Maybe during the night, satellite is the cheapest. You do a lot of download into the content cache. You could do that. LTE backhaul, you can use it for, let's say, normal traffic. So there are many of these techniques you can do, and these are really what software-defined networking is all about, really, where you are able to push the policies down into your network element when and how they should behave. So I always feel that the rural communities are really the one who want to take and will take advantage of the new technologies, even though a lot of times you hear the new technologies being applied into not so rural communities, but that's where, and that's how it should be, honestly. If the technology isn't solving a human problem, it just, let's say, increases my margin, great, but that's not really how it should be all about. It should be about how I can take that and bring it further and further. So I'll talk about a little bit about the mesh networking as well. And I know one of the gentlemen had a question about how does the mesh network scale? And I know you can't answer from Harris's perspective, but I will try to answer in general. So as you do mesh, so one of the challenge when I was sort of working on the more defense-related mesh networking scenarios was you were using a single radio. So when you use a single radio, you have the same challenge, what Charlie talked about. The problem is, in military scenarios, that's the challenge. You got the single radio, but let's say if I gave you 2 radios, all of a sudden your problem just goes away. Why? Because every link, and I'll give let me step back and explain this way. So what happens is, just pretend we are Wi-Fi and a mesh network. If I was the first node and booted up and I'm using a channel 1, John has to use channel 1 because I use channel 1. And then Charlie used to use channel 1 because I use channel 1 and John used channel 1 and so on. So everybody ends up using the same channel. You can sort of divide the work amongst the channel, but the net result is, let's say channel 1 was perfect in my neighborhood and it's really bad towards the end. But guess what? You end up using channel 1 throughout. You can't really do frequency hopping because otherwise you won't be able to communicate to me. Why? Because I have a single radio. What if I had 2 radios? So I'm using channel 1, but John may choose to use channel 2 and channel 3. All of a sudden, the problem goes away. So in the commercial world, especially when you're using these commodity components, you can afford to do that. So all of a sudden, those problems goes away. But even if, let's say, you are using the channel 1 and you want to do scaling, what you do is you deploy the techniques like fisheye, where, I don't really need to know what's beyond John, let's say. All I need to know, if I go to John, he'll get to the crowd. So I'm not broadcasting to all of you in a really massive way. All I want to make sure I have a really good connectivity to John. So that's called fisheye techniques. So you deploy these kind of techniques to increase the sort of scale and lower the chatter. But these are just these are just sort of, there are many of these techniques out there, and that's really how you scale these ad hoc networks. So what we did in how we brought that concept back into this, these are not mobile ad hoc networks, so we didn't have to do as much chatter as you would normally do in a mobile ad hoc network, because all you're doing in the mobile ad hoc network, hello, I'm here, and I see these neighbors, and you're sort of socializing these neighborhood so that you can figure out where is my tree and where is my path to go out to the end node or the egress, which is the internet. So we do the similar things, but we don't have to do as often because these are fixed nodes. But the advantage is if you take the learnings from the military background, these nodes can come and go, meaning you didn't have a good backup and there was a brownout, one of the node dies. It's just like the soldier walked away. What happens is the network automatically reroutes. Another one is, let's say you started this and you said, hey, you know what? I will really benefit by adding one more node in the middle. Guess what? It's just like a new soldier joined in with a walkie-talkie. So you take advantage of those techniques which have been there actually for last 20 years. If you Google mobile ad hoc network, the research community in the universities as well as all our defense communities, they have done a lot of great work. So taking advantage of those into this simple model and just putting another, let's call it $50 radio, you got dual radio. Life is good compared to, the other challenges you have on the military side. I'm not saying this is a military grade, it's just, it's a different world, right? So you take advantage of those techniques and all of a sudden this network becomes resilient. You can keep stretching them in any direction you want. And so let's take an example. Let's say the first radio, we call it CWS1, had a wired backhaul. You keep arbitrarily stretching this all the way. And eventually you start feeling, because now this node is seeing the total capacity coming out of all of them. Now you start to see, after some time, hey, I could use more backhaul. You can arbitrarily bring another backhaul to any of the other nodes and the traffic will automatically split. This way, now you got, let's say, two backhauls, one here and one there, and traffic will figure out. Some traffic may still want to go all the way there because that's what you programmed as a software-defined networking policies. Some may take the shortest hop, or if one goes down, you have resiliency. So this is really how you bring the network closer to the communities. Other thing you do is, let's say this was a LTE tower. We do what we call is in-band backhaul. So, I know you guys are all RF geeks, so you already know the antenna gain, right? So my iPhone, for example, those, it's probably minus 11 dBi with the body loss and everything, call it minus 6 or 7 as the antenna plus the body loss. You're looking at minus 11 dBi as a total. I call it minus 12 just for easy math, because 3 means half or double, so 3 dB means, Compared to external antenna, remember those old SMA connectors or UFL connectors behind your phones, right? If you put external antenna and you're looking, let's say, 6 dB gain, all of a sudden you're talking like 32 to 64 times the signal strength you're getting in the phone. Nowadays, these phones don't have those connectors, but we have some deployments where these links are like 21 kilometers away, and we are getting a 5-bar signal on our modem as a LTE modem to get the backhaul from the macro, which is underutilized because, again, you're on the edge of the rural side. So what happens is, because you're at a height and you have a high gain antenna, it's just physics really helping you. You can take the signal from the faraway macro and now distribute it over mesh to create some, assuming you want to keep some separation of the frequencies, you can distribute over mesh. You can light up the 4G, 3G, 4G, 3G all across. And this is a pure wireless installation, right? You don't need anything. You start that way, and maybe you use another one right here, and you got resiliency. As you start to get more and more traffic, users, then you figure out, oh, maybe there's now a business case for me to add more users. Maybe you bring a microwave or some other high capacity link into this network. But these are sort of some of the techniques we do to bring more and more closer to the users. So this is actually one of the example, right? This is a community building in UK. What you're looking from the distance is this. If you zoom in, looks like a little PVC pipe. It's a package of, it's a radome, and there are antenna clusters inside. You saw the radio, it's small. It could have been mounted right up there, but actually it's ground mounted inside a cabinet. So if this is in your neighbor's, or if this is in your home or your neighbor's home, probably your neighbor doesn't even know what's going on. So this is how you sort of solve the problem of, ugly sites in your backyard, right? And now you're lighting up 3G, 4G right here, and you're providing total wireless coverage. Let's say you are doing this 21 kilometer link or 17 kilometer link on the other one end, and all you do is pre-install the cabinet, bring it and plug it in on the bottom, provide the power, and this little antenna cluster up there which looks like a little pipe, and that's all. So this all of a sudden not only helps from the cost perspective, where you're not bringing the expensive backhaul, you're not doing this, you're also doing, you don't have to go to a big meeting and fight all your neighbors saying that I'm putting a tower. In most cases, in certain parts of the world as well as even in US, you just say I'm doing it and give a 30-day notice and you deploy it without any, because this is a single structure, single antenna, and doesn't really show as a, there are certain parameters. If you don't meet those, if you don't hit those, you don't have to actually go through those big approval process. So that's another way of saving the cost, because all of a sudden if somebody raises objection, now you got to hire an attorney who's attending the meeting, and as you know, the cost just goes really skyrocket up. So there are ways of doing it, but you have to go all across. You can't just solve the radio and not the other one. This is another one, and my friend Harlan will love this one. So this is a sheriff actually in Montana. He's installing our radio. We were at a military base 2013. These soldiers are installing these radios. This is the UK. This is the funniest one. So we were deploying the Band 14 network in Republican National Convention, and we can't bring the towers. So this is a repo man. We use their light structure to put the radio, and this is their pickup truck, and Steve Cropper, he's our VP business development, he's climbing up the ladder, just mounting up. You're just putting it on and providing power. That's all you're doing, right? Everything else is software auto configuration. I didn't spend enough time about all the automation. So there's a SON, that's the buzzword, that's self-organizing and self-optimizing network, where the software needs to figure out who your neighbors are and push the neighborhood so you can do a handoff and minimize the interference. So those are all done automatically with this, what we call is a HEPNET gateway. So it's all automatic. So all you are doing is really turning it on, putting it and turning it on, and let the mesh take care of figuring out where the neighbors are, and let the 3G and 4G be auto-configured based on what the SON thinks should be at the right power level and right different PCI and all the other configuration that goes on to it. So that's, and we have also done some of these, and some of them are very interesting. For example, this is a little bit on the public safety side. These are again LTE base stations. You can mount in a police car, behind a police car. So there's a little base station about the size of a dictionary. You can drive around with it. And again, physics is your friend, where with the external high gain antenna, you can get a really great backhauls available. We already saw this picture. We have some in the boats as well. This is actually a very cool one we did very recently, where we were actually connected to a tethered balloon. So the nice thing with a tethered balloon is it's unlimited power, because the power is coming from the tether on the ground. And these obviously are great for temporary, but they're also good for semi-permanent installation as well. The tethered balloon technology has actually improved a lot, where they can auto-detect and they can bring down the balloon in case of some things, or in case the tether gets cut, they automatically deflate. And so there's a lot more goes on to it than just a simple balloon, which we all used to know. So this is actually another great one. Let's say you're in a rural community, for probably 80 to 90% of the time, this could do a good job in coverage with as a temporary tower. And in case of extreme weather condition, you bring them down. Not ideal, but better than nothing, right? And disaster recovery and all, obviously, that's right there. So I will try to summarize this. It needs to be cost effective, but not only the hardware, it has to be all the automation, and you have to take advantage of each and every bits available to you. It needs to be plug and play so that anyone can install it. like our sheriff could do, or even taking advantage of the repo man's assets. Uh, Self-optimizing, you know, you have to automatically solve the interference problem because you're not sending RF engineers out there. So this is really what we are trying to do, and we love this. We connect all. This is, you know, the same technology applies for rural. It's the same LTE applies to public safety. The same technology applies to dense urban, really. So thank you. I'll open up to questions. Hi, Arlen.
So I have to say, I just met Rajesh today for the first time, but I have been working with his people and watching demonstrations of this equipment, and it's fantastic. It is low cost, easy to put up and turn on, as just showed you, and small. Our expectations are that this is the approach that will eventually make it possible for rural public safety to have this in the police car, fire truck, ambulance, and be able to operate where there will be poor or little or no coverage. And so I just have to attest to the fact that I've seen this operate at some of these venues that they've been doing it, and it worked.
Thanks, Alan. I appreciate. Any questions? Go ahead.
Do you foresee, from an application standpoint, instead of using the tethered balloon approach, perhaps using a solar-powered drone for short-term, perhaps longer-term coverage in rural areas?
Definitely. So I think there are two things to look at. One is sort of, let's call it lifting technologies, whether it's a tower or the balloon or the drones or even helicopters. We have actually done one with the helicopters too, you know, temporarily, right? Beaming down. The most important thing here is actually the SON aspect of it, how you self-organize. That's really the software automation. Obviously, equipment needs to be lightweight and all the power consumption, so they all play into it, the physical aspect of it. But the most important aspect of, let's say you have 5 drones and they are walking, flying around and trying to provide a coverage. So the SON, how it meshes with each other, like we saw in the mesh topology, and how you figure out the egress to go out, whether you're using, again, the LTE backhaul, satellite backhauls, or whatever those are available, right? And how you, so what happens is as these base stations move around, base stations need to know who their neighbors are. Just like in the meshing sort of thing, you need to know who your neighbors are. So when, as a phone, you're doing a handover from one base station to other base station, when the phone reports that I see these 2 base stations, I see that one more strong than you, and I say, okay, go to the next base station. Me as a base station need to know who that next base station is. So this neighborhood relationship, that's actually important. So all these things are aspect of automation. So all these things are actually the same if you step back. The same base station which can drive around, can fly around, or can be static in a mesh sense, right? But software is exactly the same. So it's definitely a possibility, actually, with a drone where you can just go completely wireless in some sense. Any other questions? Go ahead, please.
I've been talking to a rural community in Colorado that doesn't have adequate cell coverage in their downtown area.
Okay.
And they can't get the cooperation of the local commercial cellular providers to improve the coverage. In the synopsis, you talked about how this technology could be utilized by cellular providers to improve their coverage. What if you don't have the cooperation of the provider? You have a community that wants to improve the coverage and is willing to fund a low-cost solution. How do you go about doing that?
Yeah, very good question. I think one of the challenge with the licensed spectrum is you need the spectrum owner to cooperate, right? So the way I would look at it is first figure out maybe is there a smaller operator, and the reason for that is really it's all about the handsets. You know, you can go through, use some, let's say, unlicensed spectrum and build the LTE network. The challenge is getting the low-cost handsets. So intention should be try to figure out a spectrum which you can use, whether through cooperation of the big operators or maybe little operators, right? Or some unlicensed spectrum which your handset can support. So that's right, how I would look at it, and probably we can take offline and we can do some research, because we are working with a lot of, I would say, rural carriers as well. Maybe someone has a spectrum, we could light it up as long as they allow us to. Big operators are obviously a different challenge, so we could do that. Now at least the 3.5 gigahertz is coming along, and even though the handset challenges are still there, but I foresee probably in another year or two. And my simple thing is, once the iPhone supports it, I think you give 2 years, then it'll be, everybody will have it, because they'll have enough volume on the chipset side to push the market to a different level. So if you were to, let's say, use a 3.5 gigahertz today to bring LTE coverage to that neighborhood, you'll be stuck with 1 or 2 handsets and mainly the router type of devices. And sometimes you can live with that, but it doesn't scale really as a little business. You want mobility. So that's really where I think we can take offline and figure out if there is any spectrum. We can maybe get cooperation from any rural operators and then figure out a way to do it. But we can do, we have all the ingredients to do it. It's just, when you operate on a spectrum, unfortunately, you have to figure out who the spectrum owners are, and you need their permissions. And we can definitely do band 14 if that works. Yeah.
Any other questions? Rajesh, thank you very much.